going to estimate cost efficiency using this data. Because cost efficiency is just performance at a point in time, we are just going to use this Excel data. That's it. To look at the performance at a point in time. So to do that, I need to type a certain command in my RStudio. I'll go and type the command. And then I'll copy this. So I want to copy this data first. So copy this data that I've just picked here. DMU period. The headings are very important. So do Control-C to copy, Control-A to highlight, Control-C to copy. Once you copy the data, go to your RStudio. So I'm going to open my RStudio. I have opened my RStudio. Let me know if you can see it. When you can see it, let me know.
You can see it.
Yes, you can see it.
All right. So now that you can see my RStudio, I'm going to type this command number 1. So you want to type the same thing. FAM1 equal to read.delim. Double apostrophe, clipboard, close the double apostrophe and then bracket. Anytime you get to the hash sign, the hash symbol, you don't need to type anything after the hash symbol. Later on, you can go through it again with a video, and then you can, the hash symbol is simply telling you instructions after the command. It's explaining what the command is saying. So anything after the hash symbol is not needed. Once you have typed this command employs anything on your clipboard. And right now we have copied the data set in Excel. So the data set is on the clipboard. So anything that is on the cursor, the clipboard, you are going to use this command, which is here, to run that thing. And it will pick anything on the clipboard. So let's do run. You click run at the top, or you do Control Enter, and the data is loaded. So the entire data set is loaded. The question is, how do you know the data set is loaded? Well, the only way you know the data set is loaded is look at the bottom of the console. And Emily, I hope you can see the console bottom.
Yes, please.
Okay. So you look at the bottom of the console, you should see the same thing in yours as well. And you see that it's written blue. And that means that the data has been loaded. Okay. Now, how do you know with your physical eye that the data is loaded? Just go to the command 1 that I typed here. And well, let me separate this thing so they can see well. Go to command 1 that I typed here and just highlight the FAM1. Just highlight and do Control Enter. And when you do Control Enter, you see the entire data set showing down here. Showing down here. That's it. So that means that the data is nicely loaded. You are done. But you want to do something. Check the data carefully down there in the console. You see that the number 1. Let me do that. You see that the number 1, 2, 3 down here. Okay. This number 1, 2, 3, they are the rows. But I want my DMU names, A, B, C, D, to be the row numbers. So I'm going to give a command to remove that column so that the 1, 2, 3, 4, 5 is not the row names, but the row names are rather the DMU A, B, C, D, E. How do you do that? Well, you do that using this command. So this command number 2, you want to type that. And like I said, you just type up to the hash symbol. You type FAM equal to FAM1 square bracket, comma, -1. What this command does is that it will remove the first column. That is why you have -1. It will minus the first column. Anything that is in the first column will be removed. Okay. So let's run that, and then you see. Okay. Once you run that, it has been removed. But how do you know it's been removed? Let me just go and highlight farm for you to see. So when you look at farm, the first column, which was my DMU name, has been removed. But what am I going to do with it? The next command will tell you to use that rather as the row name. Let me go to command number 3. Command number 3 says row names of the farm, which is the previous command. The row names of the farm should be the farm 1 first column. In other words, rename the farm 1 first column, okay, and represent that first column with the row names of the farm. So let's run that. And when you do that, and you now go and check the farm. I'm going to check the farm now, but I don't need to type it again. It's already in command number 2. Just remember, when you first did the farm, it was down here. The farm wasn't showing the DMU. But now let's go and do the farm again. Where is that? I hope I ran the first one. Okay. So let's do the farm 1. And then let's do the farm. Maybe I need to do the farm first before I do the farm 1. So let's see which one comes first. All right. That's it. So it's showing now. Finally, I need to clear this for you to see that it's showing. So when you go to down here, you will see that now the farm, the DMU names are now the ones replacing the 1, 2, 3. So it means that you are now representing the names with the names of your DMU. So if you say Kofi, Ajua, Ama, those are the ones that will be representing it. I hope you guys understand. Now, the next thing to do is to create your input and output matrices. The first thing you want to do is to create your input matrices. By the way, which of you is doing this with me?
Doc, I am.
Okay. I have one person alone doing this with me, or others. Because I expect that if you are doing it with me and you are not following, you will tell me to hold on, you are typing or to ask a question. So I just hope that you are typing and you are following me.
No.
Sorry?
Yes, I'm doing it, but then it's giving me this error, unexpected string constant.
But that is why I am here, so that you tell me what error and how you want it, we can get it solved.
Yes, so it's with the basic, the first one. But I'm still following, and then I'm going to if I solve that string error. I have.
What is your challenge?
Was saying that unexpected string error with the farm 1. So it was giving me a past data at already in, but then
Which command number? Which command number?
Command number 1. But then I followed all what you were saying. So
you mean when you run your command number 1 and you show your results, it doesn't show the DMU? Is that what you're saying?
Yes, it wasn't showing it previously.
And when you go and check the data set, you have exactly the data set as it's supposed to be.
Yes, I have it. But I've just solved it, so I'll type in the rest of the code. I listened to all what you were saying about replacing the.
So which
1, 2, 3.
number are you on now?
I'm typing in number 2.
Okay. Christopher, where are you now?
Doc, at the row names, but when I run it, it gives me error in row names, less than, then dash.
Okay, normally I'm not so much interested in the error. I'm first interested in the command. Because sometimes dot, comma have been changed. So that's what I'm interested in. So maybe you want to read the command letter by letter.
Okay. Can I?
Yeah, yeah.
Farm 1, the first command,
No, no,
farm 1
the one that you
is
said.
equal to, okay, the row names into brackets, farm, space, is equal to farm 1. Then you open parentheses, comma, 1. Then you close the parentheses.
So this farm, by the way, you don't need a space anytime you are doing R commands. You can put
Okay.
it all together. There's no need for any space.
Okay.
That is also not to say that because of the space, that's why you have a problem.
Okay, sir.
So before the row names, you have the command which was farm equal to farm 1 into parentheses, comma -1. You had that before.
Okay, it was -1. I typed only 1.
So you see there's a problem there.
Yes, sir.
So me, I'm
Thank
not
you.
interested in the, I'm interested in the typing. So the typing is where the mistakes come from. So you correct that typing and then run that command 2 before you go to the 3. What about you, Emily?
Okay, sir, please, I encountered a little problem. My machine froze and then I had to restart. So I'm still in the process of setting it up now.
Okay.
Doc, I got it.
All right. So I just
Doc, I'm still having challenges. I have
about this at all.
sorry.
So you haven't even spoken about you doing this thing with us. It's 3 people who have indicated that they are working along with me.
I'm working with you, Doc. I'm working with you.
Doc, we are on it. It's just that we have not encountered any problem. That's why we are quiet.
No, it's not. You don't have to encounter a problem to be quiet. All I wanted to know are those who are working along with me. But there was no response except Christabel and maybe one person. So if you have opened and you are working, that is all I wanted to know. Are you people work in silence? You see, Zoom is not a very efficient way. Because I want to be sure you are doing something before I move on. Because I can do this all by myself quickly, but it's not helpful. I'm here for you. So you have to let me know that you are here for me. That's the hope.
Okay, we are with you.
Okay, so the command number 4, what it does, I mean, we could have used a certain command called attach and later detach. And that attach and later detach would have required that we don't bring the dollar symbol. Okay. So if you look at command number 4, we have brought a dollar symbol. X equal to C bind, the name of the data set, $x1, the name of the data set, $x2. What is the essence of this farm dollar? What is the essence of that? What does that mean? Friends.
Doc, please come again with your question.
Okay, command number 4, what does it mean?
We are combining the X1 and X2 columns
So if we are combining, why didn't we just write X1, X2? But we have to write farm dollar X1, farm dollar X2. Why? Christabel, why?
Doc, I think the command is trying to put together or merge two columns.
I know it is. So all I have to do, you look at the bottom here. These are the columns. The columns are X1 and X2. So why didn't I just
Yes.
write X1, comma X2?
Probably because we want to get a data frame out of it.
Yes, Michael.
So this, I think you need to specify that this X1 and X2 is being picked from farm. That's why we bring the dollar there to show that we are column binding the X1 and X2 from farm.
Now what is farm? What is farm, Michael?
Farm is the entire data set that we imported to R. It was first farm 1, and then we renamed it farm to take away the 1, 2, 3 that had been named, the DMUs had been named 1, 2, 3. We removed that column. We named that new data set farm and not farm 1. So we are specifying to R that this X1 and X2 that we are picking should come from the data set farm.
Good. You understand it? Because you see, your capacity to explain this to someone is important. It's not just copying commands and then doing it. So what you are telling the R is that I want you to combine X1 and X2 columns, all right? But for X1 and S2 columns, you have to specify which data they are in. Because there is another X1 and X2 column in the memory of R. So if you don't specify the X1 and X2 column and just type X1 and X2, it won't work. If you like, do it. If you like, go and type, let me just do it. I just want you guys to know what brings about mistakes and what not bring about mistake. So if I have normal X1 and normal X2 like this, and I do that, okay, it is going to choose something else. Okay. Let me show you what it has chosen. You see what it has chosen? That's the X that we have here. If I go and plot that X, it has chosen something else at the bottom here. This is not what I'm looking for. This is not my data set. This is not my X1 and X2 column. So you got to specify where you are picking the data set from. So once you say that it's from farm, and the dollar is simply indicating that you read it backwards. So X1 is from farm and X2 is from farm. You read it backwards. And when you run that, okay, let me run that and show you now the X. When you go and show down the X, tell R to show you the X. He's now telling you proper X1 and X2, exactly as you have it in your data set. Emily, do you understand?
Yes, sir.
So it is one thing that a person has used R, okay, and so the person can use R for other things. No. Every other thing that you're using R for, one needs to learn the language for that purpose to be able to smoothly sail through. All right, so now we know our matrix. So this is actually a matrix of X. And the matrix of X is made up of two vectors, vector X1, vector X2. You got to do the same thing to Y. Remember that in real life, you may have X1, X2, X3, X4, X5. You may have actual long names for them. For example, X1 is labor, X2 is capital, X3 is materials. But it's always good to rename these things with X1, X2, X3 so that it doesn't become too long in the in your eyes. Because sometimes when the command is too long, you can't follow through. You can acronymize it. Some people will even say, X. They'll use different letter to represent it. Okay, so letters are good. Singular letters are good than words. So let's do for the Y. For the Y, we are going to do the same thing. We are going to column bind all the Y. The thing about the Y is that in this very context, the Y are not many. There's only one Y. The Y is just one. So if you look at the C bind, I am doing farm dollar just Y. I'm not doing Y1 and Y2. That's not what I'm doing. I'm just doing Y because Y is only one column. And how do you know that? When you come down to the data set down here, you will notice that the Y is just one column here. Okay, so you run that as well. Normally, I advise that whenever you run, you go and highlight it and then show it. So you highlight and run again. It will show you what you've just done to be sure that that is what is happening. The next is the input prices. Okay. The input prices. The input prices were all 3, 3, 3, 3, 3. And because they were all 3, 3, 3, we can just use a single matrix to column bind again all the inputs. Indicate that it's 3 for the first column, it's 3 for the second column, and it runs across. And the number of columns are 2. So NCL is the number of columns where you are specifying that the number of columns are just 2. And so when you run it, let's run it. Okay, you go and see how it looks like. Go highlight the W, see how it looks like. It gives you the column for these DMUs. But of course, remember that it will pick all of them. It's just using this, but it will pick all of them with the same number. Okay, now that you are done, okay, there is another approach. Okay, let me see what I can use that approach here. Gene, let me call it Gene. Okay. In this approach, what some might do is that they might have the farm with the W1 and the W2 showing. I'm just going to run that for you to see. So if you have the gene, you can use that depending on the situation. That one will also look like what is down here below, but it's the same thing. So we can use either of them to indicate it. The number of columns here will indicate the whole situation. Once you are done with that, you can invoke your benchmarking. The benchmarking is a package. I'm sure you have all installed that package. If you have installed the package, all you have to do is to invoke that package by typing it and then running it. So when you run it at the bottom, you will see that the benchmarking has been invoked. So you are now ready to estimate your plots. Now, what I'm going to do is not compulsory, but it's always nice to have something from a beginner. And when you're writing a thesis, you want to plot your data set in R. Sometimes some will rather want to do it in Excel. Either way is fine. But it's nice to know that R can also do it. Okay. So you want to plot the data set. How do you do that? Choose plot, give the names as farm1, farm X1, farm X2. The color, I use blue, you can use any other color. The line width is a 7, okay, that's a line width. The position of the number of the plot is 8. The location of the plot with regard to the whatever number that will come is 1. The texts are true, which means that you can give it a title and then you will write the title. So let's plot this and see how it looks like. Now you can see my plot. I hope you do. Do you see my plot? Now you can see that my plots are tick blue. Okay, so you can reduce the tick blue. I can reduce it. Go to the line width, you can change it to 4. Okay, let me plot that again. It becomes smaller. Okay, go to the line width, let's change it to 2. It becomes even smaller. So you can use any, the size to indicate how you want the thing to be done. Now, once you have plotted it, and by the way, you should be able to check spellings every time. Once you've plotted it, the next one is to draw your DEA frontier. So that is the next command. Okay. To do that, yes, Francis.
Doc, my plot did not come. I don't know why.
So first thing you want to do is to check your spelling.
Yeah, it's the same thing. But then I received error in plot.window.
What did the error say?
The error says error in plot.window, then need finite xlim values. In addition, warning message.
Okay. So inside the plot, you have farm $x1, right?
Yes, farm $x1, comma, farm $x2, comma, COL color equals to blue, comma, LWD.
Do you have double apostrophe before the blue?
Yeah.
Continue.
So it's in quotation commas. Then we have the lewd equals 7, comma, psych equals 8, comma, sex equals 1.
The line width, instead of 7, make it 2. Let me see something. Make it a space. Make it 2.
Okay.
And then continue.
Then there is psych equals 8, ECH equals 8, then CX equals 1, then text is true. Then main equals DEA isoquant.
Is that also in double apostrophe?
Yes, double apostrophe, then the bracket is closed.
Is that true? Is it capital?
Yes, the true is in capital.
Have you invoked library benchmarking already?
Yes, when I did it, it said loading required package, just like what you said, but I didn't state whether it was done or not.
No, it's okay.
So yeah.
Doc, me too, mine is not displaying the plot.
Do you have a portion of your graph, like I have here, indicating that, with a space, with a very good space, or it is all squeezed to the
No,
right?
it's with a very good space.
All right, okay. So first thing I would say is you check spelling. You've got check spellings. It appears that, but when you use the Y, when you go and highlight the Y alone and you run it, what do you get? You get a 111. Did you highlight each of your X, Y, and W to get the results as I did?
Yes, sir, Doc, yes.
Okay, I did not do for the Y. I just did for the Y. It says now.
So it means Y is not even there. So you didn't run your Y. So you have a problem in the first place.
Oh, okay.
You should run everything. Now let me go back to Christopher. Christopher, you said you run everything.
Yes, sir.
Okay. And then what did your library benchmarking say?
It just said error. Error in library benchmarking.
So it means you did not load it. That's what it means.
But it's highlighted blue.
Oh, no, it's not just the blue. But below the blue, there is an error, right?
Yes.
There is nothing loading. Anytime there is loading is different from error. Error means serious. Okay. And the fact that it's blue doesn't matter. Even if it's an error, you always get blue. So the blue doesn't matter. But the word error is an important. The word error is different from loading and warning. So that error means that your library benchmarking has not been effective. My question is, do you have library under packages? Click on packages.
Yes. So the benchmarking is ticked.
Untick it and tick it again and tell me what it says.
Okay.
Doc,
Yeah.
hello. Hello.
Yes.
Hello. Yeah, Doc, please, can I have a look at the first 4 quotes? I just want to make sure.
Yours or his.
Okay, thank you.
Christabel, I'm waiting for you.
Sir, please, they wrote detach package benchmarking, then onload is equal to true. Then under there is library benchmarking again. Then another one, loading benchmarking versus version 0.30H. Then
0. What?
greater 0.30H, revision 244, comma, 2022-0505, 16:3131.
Okay, you know what? All I want you now to do is I want you to run the library benchmarking again.
Okay, sir. Sir, please, is that error in library benchmarking? Could not find function library.
Yes, so it means that the library is not working. That is the first problem I observed, even though it's in this. So there are 2 things you want to do. You are going to close the work, reopen the work, and then you copy the data as we did, and then come and run all the commands again and let me see.
Okay, sir.
Your type command,
Yeah,
as long as you are saving, it will be there.
Okay, sir.
Doc, please, I've gone back to run from the top, from the clipboard top by copying the data set and putting it in the clipboard. But when I get to the X equals to the C bind, when I run, it moves. But when I come back to check if the data is in the X, it comes back as now.
For the X2.
Yeah, on the X. No, the X1 and X2 brings the figures out, but the X equals to the C bind. The X itself comes as now. The Y2 comes as now.
X equals to the C bind, and you check it. It doesn't show.
Yes.
Okay. Now, did your farm1 show?
Yes, my farm one shows. Let me check it.
You see, the solution is obtained because you are running the work. You are getting the mistakes. That is why you are solving them. So if you are not doing it along with me, you will not be able to see some of these problems. You talk about the problem, I'm able to detect where the problem is and the solution because I've been doing it. So the same thing, you have to work along with me, and then you be able to be handling the problem as you go. But to say that, oh, I'll go and watch the video and follow and all of that, it doesn't really work normally that way. So it's important that you are dirty on the ground with me. Yeah, it is. So who has been able to draw the isoquant? I mean, the plot the thing.
Doc, I've been able to do it.
Who is talking?
Michael.
Okay, so you have your data plots.
Yes.
Okay, so continue and type the command number 9 for the isoquant we are about to run. Who else?
Then I think that's
What?
I said I've done that one too, and it has drawn it has plotted the line in the envelopment. It has done the envelopment.
Okay.
Yes, Doc, I have it now. Thank you.
You have the plot now.
Yes.
Okay, so you can proceed with the isoquant. The isoquant I have here is a red one because I use a red color. If you use a different color, you get a different color. So I'm waiting for the others. Christabel and Emily, what's happening?
Look, I'm still trying to install the library benchmarking.
Okay. Prof, I'm almost there. I'm now on the command 5. So I'm hurrying along.
And do you normally run it to be sure of what it's supposed to be?
Yes, Doc. Everything is coming along. So far, no errors.
I hope you are not typing the green instructions, are you?
No, please.
So when you are typing, once you get to the hash symbol, that's the end.
Yes.
All right, okay. Okay, so for the command number 9 is a DEA plot. The DEA plot, sometimes when you put a cursor on it, it will even tell you what you're doing. The DEA plot requires that you give the input, the X and Y graph information. The X information I have it as farm $X1. The Y information, I have it here as farm $X2. Then you have to specify the orientation. The orientation I have here is input orientation, IN. The return to scale is CRS, and that's constant returns. If you use variable returns, it will give you the same thing because the plot doesn't specify the orientation, the return to scale. Then you can see that the line width is 7. I can reduce it to 4. The position of the plot relative to the line is 1.25. The color is red, and the title remains as it is. So when you do that, you will get this nice plot that some of you have already done. But then the plot doesn't have the names of the DMs. So the next command is going to put down the names of the DMUs into the plot. The names of the DMUs into the plot. The CX is 0.6. I want to change the CS a little bit to 1.6. The position is 3. Sometimes the position will tell you that you should be above the plot, below the plot, on the right of the plot, on the left of the plot. Okay. The color here is blue. Okay. I want to change the color from blue to yellow. Or let me even say from blue to purple. Okay. And if you're using the latest version, once you type it, it will color it for you as well. So what are we doing? What are we doing in command number 10? Command number 10 is going to just label the dots, the scatter plot. And you are telling it that put a text on the scatter plot, and the text should be the row names inside the farm. So if you look at this at the bottom here, the row names inside the farm are the A, B, C, and all of that. Okay. So it's going to write the names for the DMs. Now you have seen all these things already. We are just plotting it into it. So do all of that, check spellings, and then boom. Once you do that, you can see, like I have here, they are all located on top of the plot. That is the position 3. If I change it to position 1, let me run that for you to see. Okay. Is it? Position 4. Okay, let me see. So that's it. It's showing the positions now that at first it wasn't, it was delaying. So the position 4, we'll put it below the position 1, we'll put it on the right. So I want it all to be on the right. So let me just go back. I think my computer is a bit slow. Let me just go back and show the positions. We'll show the plot again. So let's do the plots again. Okay, so we've got a plot. And position, like I said, position 1. We'll move it to the right. Okay, position 1 is rather below. So position 4. The problem is that it adds to it. So I just wanted to go back.
So position 2 is better.
Sorry? What did you say?
No, I said position 2 is on the left.
Yeah, I want position 4 because position 4, the 10 will be on the right. Okay, but the 10 is that when you come to the horizontal ones, they will be on the line. Okay. Anyway, that's what you guys can see there. You can see that we have been able to label each of the axes. We've been able to label each of the axes. What's the next thing to do? The next thing to do is this command, and this command is a very tricky command. Okay. This command will draw the radial line. You know, in DEA, you have to have a radial line, and this is the command. Okay. It's quite a tricky command. If you are not able to follow through this one, don't worry, you can do it later. But I want you to know, this command, we start with 4, okay, I in one length, okay, you give the radial line, taking into consideration the inputs, the outputs as well as the inputs. Okay. And you want the line to be dotted, like zigzag dotted. The line width is 2, the color is blue. Let me think of the line width is 2. I want to make the line width a bit thicker, so I'll move it into 4. The color is blue. I want to change the color blue to Alice blue. Alice blue. If you look at Alice blue, the color shows a bit different. Give me some cool colors. Steel. Let me see. Steel. No. Teal. No. And so yellow. Let me give some yellow. Once you do that, you're going to get the radial lines. And that's what you can see mine is showing there. Yellow is too biting. So what are some of the colors you know of? Okay, some of those colors that you know of, and then work with them. But even black is there. So you can use black. So this yellow is white. The line width is also too thick. I'm going to reduce it. Okay. So the line weights, we'll make it 3. And the yellow, let me make it black. By the way, these things is because you guys are, I'm waiting for you. That's why I'm doing these changes. Otherwise, they are not too problematic. Anyway, so you can see what I've done there by showing the frontier and the radial line. So the rest of you, let me know where you got into before we move on, because we are delaying. Where have we got into? Christopher, where are you now?
Doc,
Where are you now?
still the benchmarking is not working.
So you know,
But I think I made a mistake in typing the command number 8. So I'm editing that.
so the library benchmarking is not working.
Yes.
Even when you take it in the packages section.
Yes, sir.
So the problem is likely that you are using a different RStudio from the benchmarking version and things like that. So the one possibility is to uninstall
this one and reinstall.
Yes.
Okay.
You know how to do that.
Okay, sir.
I'm asking whether you know how to uninstall.
Yes, sir.
How? How do you uninstall? Because it's a package. So how do you uninstall?
I'll go to my applications.
No.
Then I'll uninstall from there.
Package. So it's not, it's inside the R studio. It's in the memory of the R. It's not inside your computer.
Okay, sir.
You can uninstall the R and the R studio on your computer.
Yeah, that's what I intend doing.
No. It's just deleting a package.
Okay.
Well, my computer is a bit slow. I would have shown you. Okay, so what about you, Emily? Where have you got into?
Okay, Prof, I'm on the command 8. I did it the first one and they said unexpected.
So command number 12 is going to generate the isocost line. Add line into bracket A optimum cost. That is cost optimum. C opt is optimum cost. And this gives you the slope. Okay, the slope of the isocost. That is what it gives you there. The color is green. The line weight is 4. And it's a dashed line. So when you go and actually look at the slope is the same for each one. Okay. Whether it's for the W1 or it's for the W2, the slope is the same. Okay. So that's what we have here. So when you run this command, it will give you the isocost line. Okay. It says that co-opt is not found. So it means that there's a I'm even having a bit of a challenge for that. Let's see. Oh, co-opt is not found. Let me find out why. Okay. All right. So let's go to, we've done our isocost already, presumably. So let's go to our technical efficiency score under constant returns. The C here means constant returns. The T is technical efficiency. And we are using the X, the Y, the returns scale is CRS, the orientation is input, and then slack is true. So let's run this command and then show the results down there. I hope you can see the efficiency score. You can run the same thing and notice your efficiency score. So when you run it, you will notice the efficiency score for constant returns, 1 for the DMU A, 1 for DMU B. When you look at the graph, it's not surprising. All of them are 1, 1, 1, except E, which is 66.67. So we know this already. Okay. Then you go and run your variable retention scale. That's command 14 here. TV, you can copy the same thing as before and just change the TC to TV and change the CRS to VRS. Because it's the same environment, you get the same score. So when you run this one and show the results, look at the console, you will see that you get the same score as the CRS. It's not surprising. Let's go to the scale efficiency. Once you want to see the scale efficiency is the technical efficiency under CRS divided by technical under VRS. So when you run that, you're going to get 1 because they are the same. Truly, that gives you 1. Let's show the slacks. The slacks in this situation. You show the slacks by writing SL. SL is the name I gave to it, which is slack of the input and the output, under CRS. So the TC is under CRS. If you want to calculate under VRS, you write this, TB. When you do that and show, it will give you the slacks. Okay, and that is the one that is one. This is the combined slacks. The next one is the next one is an important one because now you're going to the cost. Okay, so let's go to the next one. Command 17. I call it X-opt. X-opt is the minimum input. Remember, I told you that you cannot get the minimum cost first. You need to, for example, if you look at E, you need to move E to the frontier, the isoquant, before you move it to the isocost. So the minimum input for each firm is going to be calculated as cost.opt. Cost.opt means optimum cost. That's what it means, optimum cost. Okay, given with the input, output, and the prices under CRS. Okay. I'm doing everything under CRS for now. And if you want to do it under VRS, it's just changing the C to V. So if you run that, it will give you the minimum cost. So let's go and see. Okay. If you show the result, you will see that the minimum input, okay, the minimum price for each input is being given here as 3. The next thing to do is to calculate your minimum cost. Now that you have your minimum input. And let me share something with you. If you look at this minimum cost under 18, it is given by the minimum input, which is the X-opt, multiplied by this symbol, percentage is simplest. It's trying to take the transpose of the prices. So if you look at it, the prices are 333, that's a W. The T here is a transpose. So once, this command is saying that once you get your minimum input, you multiply the minimum input by the corresponding price to get the input vector that minimizes the cost. Okay. So this is going to give you the minimum cost for each DMU. Let's run that and go and show the results. And you can see that the minimum cost for each DMU is 18, 18, 18, 18, 18. Now that we have the minimum cost, we can easily find our observed cost. The observed cost is given by just the input multiplying the price. We notice this. Just the input. The price is the W. The input is the X. And because we are taking the transpose of the price so that we can nicely multiply, that's why we bring the percentage times percentage symbol. It's a nice way where you are multiplying something that is not a transpose with something that is a transpose. When you do that and go and show your observed cost, you will notice that the observed cost for each DMU is 24, 18, 21, 30, 31.5, just as we got it. So the R is giving you the result straight away. Now that we have the minimum cost and our observed cost, we can go ahead and find, finally, our cost efficiency. And we know the cost efficiency is the minimum cost over the observed. So let's run that and show the results. And you'll see that just as we had a cost efficiency for DMU A to be 0.75, it is showing that clearly here. And the cost efficiency for E, it is 0.57. That is also shown down here. Now we can find allocative efficiency because we have calculated our technical already. Allocative efficiency is given by the cost efficiency, the one we just found, divided by the technical. Okay. Remember, this is all under CRs. Okay. And when you do that, then run, the allocative efficiency for each firm will be given here. All of them will have the same score except E, which had a difference between the technical and the cost efficiency. So we got allocative efficiency. Now we can put everything together. Okay, we can put everything together here. What is that everything? Well, the everything is, and this is an important command, command number 22. I'm putting everything into a table so that it looks beautiful, but I'm converting all the answers into rounding them into 2 decimal places. Okay. So I'm converting every answer into 2 decimals. So round, and then everything will be inside, and then digits. Round to how many digits? 2 decimal places. So what are the things that we are going to create a data frame for? We are creating a data frame for the data set, which is farm, for the observed cost, for the minimum cost, MC, for the cost efficiency, CE, for the allocative efficiency, AE, for the technical efficiency, TE, for the pure technical efficiency. Okay. The pure technical efficiency required that I must have run the VRS, and I did, we did. Okay. And then for the scale efficiency, we did that. Then for the slacks, we did the slacks. We did all of that. So now we can show the results in rounded situation. And at the bottom, man, ladies and gentlemen, at the bottom, you see the beauty being shown right there. Okay. So you can see right here, the beautiful thing that is happening. Okay. I don't know whether you see the beauty, but beauty is on the way. So you can see that all of these, they are showing that even the slacks, okay, this DMU D had a slack on the input side, slack 3. DMU A had a slack. You can see it here. Okay. You can see it here. It had a slack. Okay. Because once it is on the, what do you call it? Once it's on the free disposable line, it is exhibiting some slack here. And then on the output side, nobody exhibited slack. So slack is 0. The pure efficiency scores are shown here. The allocative has shown there. The cost is shown. The observed cost is also shown here. And then the minimum cost is on it. It's just coincidental that in this case, the minimum cost happened to be 18 for all of them. But in reality, and when we come to productivity, you will see that the minimum costs are different. So this data set is a beautiful data set. So one thing one can do is to send the data set into Word. That's what we do. How do you send it to Word? Well, once you copy this data set, okay, you copy it. Sometimes you have to do it twice or thrice. You copy it, you go and open your Excel. Let me open an Excel here just to give you a glimpse of what I mean. Okay. So I'm going to Excel. I'm opening an empty Excel. And I've just clicked one sheet. Okay. I've clicked one sheet. Let's say cell D1. And then I click Control V to paste. Once I click Control V to paste, everything is pasted, as you can see, but you don't touch it and go to Data tab. And under Data tab, you go to Text to Columns. Once you do Text to Columns, you can see how you can arrange it all in columns. You can see the preview here. Okay. So once you click Next, you can see that they are all nicely arranged, and click Finish. Once you click Finish, beautifully, everything is nicely arranged, as you can see here. The only thing that didn't come was the headings. Okay. But that's no problem. Okay, you can just do that. But sometimes, most of the time, the headings will come. But let me see what I can show it where the headings come automatically. So what I'm doing, you will see, but I'm going to copy the entire data set again. I'm just copying the entire data set again, this time with the headings. Come back to the here, and now do text to columns, okay, and everything will be nicely organized, including the headings. There you go. So you can see that the headings are there, everything is nicely organized into Word, and at this stage, you can just highlight them, give them a proper, numbering, center align, whatever you want to do, and it's nicely arranged. And you can talk about it in your methodology, in your findings. You can talk about it in your findings. So that is how you generate efficiency scores, cost efficiency scores. These are all the important things you need to show how you calculated your cost of it, if that's the only thing you are doing. Okay. That is how you execute this fine analysis. Okay. Sometimes, if there are many, you can just do a graph. You can, at this stage, generate descriptive statistics of the data. You can find the mean, the median, the skewness, the kurtosis, the standard deviation, the maximum, the minimum. Okay. If there's a large data set, you can do graph, timing, lining, and all of that. If there are groups, you can segregate them and do cross tabulations and several things. Okay. That's for another day when I'm teaching you those things. But that is how, this is exactly how you find your work. Let's go back to the R Studio. So that's it. This is cost efficiency. And what I'm going to do is that next time we're going to do cost productivity theoretically, and then show how you estimate cost productivity. Now, mind you, this is cost efficiency, but this is just for one cross section. When we are doing productivity, we have to do 2 own period efficiencies and 2 cross period efficiencies. This is just one of the 2 own period efficiencies. Okay. Measuring everything in year 1 relative to frontier 1. That's it. What a joy. What a joy. You all have your efficiency table, but the one I have here, only one firm was cost inefficient. Okay. If you look at it, what I mean is that only one firm was more or less inefficient in technical sense. In technical sense, majority of them were efficient. So you should have, where you have a lot of diversity, create your own data set, and then let it be more than 5 DMUs, show some slacks, more slacks, and more inefficiencies, and then generate a new data set like this that shows everything. Because you use this in your paper or thesis. That's it. So at least now you know how to estimate cost efficiency, and you also know how to interpret it, and congratulations for that.